Okay, so now we're going to go over lesson 8.2, and that's on page 451. And the objectives say determine whether systems of equations are consistent or inconsistent, and determine whether systems of equations are dependent or independent. Special linear systems of equations. When you graph two linear equations on the same coordinate axis, one of three things can happen. The lines may intersect. The system has one solution. So if you look at that graph, the lines intersect and they have one solution at the point 1, 1. Okay? Those are the kind that we looked at when we learned how to solve systems of equations by graphing and by using tables. The next thing that can happen is that the lines may be parallel, and so the system has no solution. Okay, and then the third thing that can happen is that the lines may coincide, and that means that the system has infinite solutions. So if the lines are parallel, the system has no solution because the lines do not intersect, ever. If the lines coincide, which means they are basically the same line, then the system has infinite solutions because they intersect at every point. Okay? Let's turn the page to page 452, and let's read under independent systems of equations. In the worlds of agriculture, business, engineering, industry, and science, systems of linear equations model many problems. Most of these linear systems have single or unique solutions, meaning they intersect one place. A system of equations that has at least one solution is consistent. If the system of equations has only one solution, the system is independent. So that's important to remember for this lesson, that if a system of equations has at least one solution, it is consistent. And if it has only one solution, it is independent. Now, look at the activity there. It says modeling profit in a business. Kikia's younger sister wants to earn money by selling lemonade. The cost of starting the business is $1.20, and each cup of lemonade costs 6 cents to make. The expenses in dollars, D, are equal to 6 cents times the number of cups sold, N, plus the $1.20 startup cost. So D, which again is the expense in dollars, equals 0.06, which is the 6 cents that they charge, or the 6 cents that it costs to make the cup of lemonade, times N, which is the number of cups sold, plus the $1.20 startup cost. If the lemonade sells for 10 cents a cup, the income, D, is equal to the 10 cents times the number N of cups sold. So D is equal to 0.10, or 10 cents times N, which is the number of cups sold. So how does this graph model the profit or loss for this business? If you look at the graph that they've created there of the systems of equations for this problem, you will see that they have the lines drawn, and they want to know, how does this graph model the profit or loss? Well, the horizontal axis represents the numbers of cups sold. Okay, so if you look at the horizontal axis, or what would be the x-axis, that represents the number of cups sold, and then the vertical axis, or the y-axis, represents the dollars. Okay, and the point of intersection of the income line and the cost line represents the break-even point. So that's how you know if you've made a profit or a loss, because you have your break-even point there. Okay. Number 2, what does the point 0, 0 mean on the income graph? If there are no cups sold, there is no income. So the point 0, 0 represents where there are no cups sold and there is no income. Okay, number 3, what are some of the startup costs? Okay, so for example, some of the startup costs could be the cost of cups, signs, advertising could represent startup cost. So that can vary depending on what you use to start up your business. Number 4, if she sells 20 cups of lemonade, what is her profit or loss? So if she sells 20 cups of lemonade, her cost is 20 times 0.06. Remember, 6 cents is what it costs to make a cup of lemonade. So if she sells 20 cups, it's 20 times 6 cents, 0.06, plus the $1.20, which was the original startup cost, which equals $2.40. And she makes, she's charging 10 cents a cup times 20, which is equal to $2. So she loses 40 cents if she only sells 20 cups. Number 5. If she sells 40 cups, what is her profit or loss? So if she sells 40 cups of lemonade, her cost is 40 times the 6 cents that it costs to make the cup of lemonade plus the $1.20 that it costs to start the business. And that is equal to $3.60. And then she makes 40 times the 10 cents that she's charging, which is $4. So her profit then is 40 cents. Number 6. What are the coordinates for the break-even point? Okay, if you look at your graph there, you'll see that the break-even point is 30 cups and $3, or 30 and 3. 33 is the point where both lines intersect. Okay. Number 7. How many cups must she sell to make a profit? All right, and she must sell more than 30 cups because that's her break-even point, okay? That's the amount of cups that point represents at the break-even point is 30 cups, so she has to sell more than that to make a profit. And then number 8, is this system of equations consistent and is it independent? The answer to is it consistent is yes, because it has at least one solution. You see the lines do intersect, so it has at least one solution, so it is consistent. Is it independent? Yes, because it only has one solution. It only intersects at one point, so it is independent. All right, look at page 453. It says a system with no solution is inconsistent. Okay, so if a system of equations has no solution, it is inconsistent. The graph of an inconsistent system is parallel lines. Recall that parallel lines have equal slopes but different y-intercepts. Parallel lines, non-vertical lines are parallel if they have the same slope. Vertical lines are also parallel even though their slopes are undefined. Example 1 says, solve the system of equations. Negative 2x plus y equals negative 1. Negative 6x plus 3y equals 12. And the solution to this is to use graph paper or graphing calculator. First, write each equation in slope-intercept form. And so they solved those equations for y, and they got them in slope-intercept form. Then they graphed each equation on a coordinate grid, as you see there on page 453. And if you notice, the slopes in the two equations are equal. They're both 2x. But the y-intercepts are different. In the first equation, the y-intercept is negative 1. And in the second equation, the y-intercept is 4. Therefore, the lines are parallel, because that's the rule about parallel lines. Their slopes are the same, but their y-intercepts are different. There is no solution to this system, and it is inconsistent. So look at the ongoing assessment on page 454. Okay. It gives us two systems of equations, and it says which of the systems is inconsistent. So we're going to solve for these systems, and we're going to figure out which one represents systems that are a system that is inconsistent. So let's look at A. X plus y equals 5 is one equation that we're given, and x minus y equals 3 is the other. Let's solve for y. So we'll have negative x. Well, we're going to subtract x here, actually. And we'll get y is equal to negative x plus 5. All right, and then the other one is x minus y equals 3. So we're going to subtract x from both sides again. And we get the negative of x, or the opposite of x, is equal to negative x plus 3. And we know that this means the opposite of y equals the negative x plus 3. So we just need to come and change the sign so we can find out what y is equal to, because we don't want a negative y. So if we change the signs, we get y is equal to x minus 3. Okay? And then for b, we have x plus y equals 5, so we're going to subtract x from both sides, and we get y equals negative x plus 5, which is the same as the first one we did in A. And then x plus y equals 4 is different, however, so we're going to subtract x from both sides, and we get y is equal to negative x plus 4. Okay, so I'm going to graph these. For this one, our y-intercept is 5. Then our slope is negative 1 over 1. So, hold on. Okay, oh my goodness, it's giving me trouble, y'all. Okay, so we have our y-intercept at 5, and then down 1 over 1. 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 And I'm going to go ahead and draw that line there. Okay. Then I'm going to go ahead and graph this line. This line intersects at negative 3. So, alright, so let's go to negative 3 and make our first point. Then our slope is 1 over 1, so we're going to go up 1 over 1. 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 So I'm going to go ahead and graph this line. Now, you can already see, based on this, what just happened here, that A is not inconsistent. This system of equations has a break-even point. It has an intersection. So it has a solution. It has exactly one solution. It intersects exactly one time. Therefore, this system of equations is consistent as well as independent. Okay? So we know that the answer is B, but let's go ahead and graph ourselves how it looks. Okay? So the first equation in B is intersecting at 5 again. It's actually this line here. It's the very same line. So I'm just going to go over it in blue. Okay. And then this one intersects at positive 4. Okay, and then the slope is negative 1 over 1. So we're going to go down 1 over 1, down 1 over 1, down 1 and over 1. Down
You talking to yourself?
And over 1. Shh, no, I'm videotaping for class. Sorry about that, guys. All right, and then I'm going to draw a line to show this line. And as you can see, they're both they're parallel lines. They both have the same slope, which is negative 1 over 1, but they have different y-intercepts. So they are parallel lines. So B is an inconsistent system of equations. So look on page 454. It says dependent systems of equations. A system of equations is dependent if all the solutions are the same, which means there are infinite solutions. Dependent systems of equations are also consistent because the systems have at least one solution. Okay? In example 2, it says solve the systems of equations 4x plus y equals -2, 8x plus 2y equals -4. And the solution is to write each equation in slope-intercept form, of course. Okay, and so they solve the equations to solve for y and put them in slope-intercept form. Then they graph the system of equations on the same coordinate plane. And as you can see, both equations have a slope of -4 and a y-intercept of -2. Therefore, the lines coincide. They're basically the same line. And the system of equations is consistent and has infinite solutions because they intersect at all points. So explain the difference between the following three systems. A system that A says a system that is consistent and dependent. So a consistent system has at least one solution, and a dependent system has infinitely many solutions. So that's the difference, okay? And then B says it wants to know the difference between a system that is consistent and a system that is independent. So for B, a consistent system has at least one solution, and independent system has only one unique solution, okay? And so that's the difference between those two. And then C wants to know the difference between a system, and then C wants to know what a system that is inconsistent looks like. And an inconsistent system has no solution because the lines are parallel, so they never intersect. So that system is inconsistent and has no solution. Okay, so write down any questions, and then we will talk about them tomorrow, and I'll see you then.